Hi, welcome to my channel Too Irrational. I'm Pranesh Sharma, and in this video we are going to see solutions of CS1 paper A conducted by IAI Institute in March 2022. We'll go through each question from start to end, and if you want to skip to a specific question, there will be marking in the timeline. If you want the complete solution file, all you have to do is WhatsApp or Telegram us on the number that I have given in the description, your email ID and the subject for which you want the solution, and we will email you the files. Now let's get started and see the first question. For the first question, we have assume for a health insurance policy, the number of claims follows a Poisson process with a rate of 0.3 per year. Determine the probability that no claim arises in the policy in 1 year. Here we are finding probability x is equals to 0 for this Poisson distribution. And for the policy, determine the probability that out of 4 consecutive years, there are 1 or more claims in the 2 years and no claims in the remaining 2 years. So here we are going to make a binomial distribution. Let me show you how. So for the first part, we got probability that x is equals to 0 is this. Now we'll say n is following a binomial distribution, n being the number of policies that do not have any claim with 0 claims. So we have total 4 policies, out of which probability of having 0 claims would be this. We got it from the first one. We are saying 2 of them are having claims and 2 of them do not have claims. So we have 4c2 theta raised to 2 1 minus theta raised to 2. So we get probability as 0.221199. So the third part, assume that a claim has just occurred. Determine the probability that more than 3 years will elapse before the occurrence of the next claim. We know time between 2 occurrences of a Poisson distribution would follow an exponential distribution with the same parameter. So that is why time in years between 2 Poisson occurrences follows exponential 0.3. So we are finding probability t greater than 3. You can take f from the table book and we get the probability as 0.40567. And for the health insurance policy, provide the steps to be followed in order to simulate an observation of n numbers of claim occurring in 1 year, and in the fifth part, using the following 2 random numbers uniformly distributed between 0 and 1, simulate the number of claims in 1 year for the above health insurance policy. So in the part 4, we have to write down the steps. In part 5, we have to show the simulated value. So in part 4, we are saying first generate a value from uniform distribution. Next, find the CDF of the Poisson distribution. Then we'll say if the generated uniform value is between a certain CDF, then n becomes the simulated value. Then in part 5, we are calculating from the table book page number 175. This is our CDF of Poisson distribution. Our u values u1 and u2 are given here. Now because all our uniform value were definitely less than 0.96306, we did not need any of these values. Okay. So you could have just written your CDF as this with 0 and 1 value. That would have worked too. Okay. So here u1 is 0.7521, that is between these two. So therefore x1 would be 1. And u2 is 0.65, that is between these two. So our x2 becomes 0. Now let's go to our question number 2. In question 2, following measures are provided for 2 independent random samples. So we have sample size summation x and summation x square given. The sample mean for both the samples is 19.8. So mean is given to us. Calculate the sample variance for both the samples. So this is our sample variance formula. Calculated S1 square and S2 square for that. Then in second part, assuming that the samples are drawn from a normally distributed population, carry out a test of hypothesis H0 mu is equals to 18 versus H1 mu not equal to 18 at 98% level of confidence for sample 1. So if they say 98% level of confidence, that means we have 2% level of significance. So our test statistic is going to be x bar minus mu upon s by root n follows t n minus 1. So our observed value or the statistic value comes out to be 2.7587. P value, because we have not equal to, we'll get 2 times probability greater than 2.75. So we get our p value is going to be between 1% and 2%. So at 2% level, we have sufficient evidence to reject H0, and hence we will say our mu is not equal to 18. In B part, calculate confidence interval for sample 2 to test the null hypothesis stated in sub part 2A. So for the same hypothesis, mu equal to 18 and mu not equal to 18, now we have to calculate the confidence interval. That means we are calculating 98% two-sided confidence interval. So we have our 98% double-sided confidence interval, x bar plus minus, t value is going to be for 1% and degree of freedom n minus 1, that is 14, s2 by root 15. So we are getting our confidence interval as 16.564 and 32.036. So clearly 18 lies in between our confidence interval. So we'll say at 98% confidence, the mu is equals to 18 is possible. So that would be our comment here. Now for the C part, they are saying discuss the reason for the differences and the similarities while comparing the test results of sample 1 and sample 2. So we're saying as the variance of sample 2 is greater than that of sample 1, the confidence interval for sample 2 is wider than that of sample 1. Even though the sample mean is same and the sample size is same, the possible values of population mean has a wider range in sample 2 than that of sample 1. D part, a new 100 size sample 3 is collected from the same population. Explain how the width of the confidence interval of sample 3 will differ from the confidence interval of sample 2. So saying as the sample size increases, the width of the confidence interval decreases. Hence, the width of the confidence interval of sample 3 will be significantly smaller than that of sample 2. You can say here that the value of mu would be much more precise, or you can say because the width is smaller, that is why we will have a much accurate value of mean. You can add that here as well. Okay. E part, it was observed that one of the claims in the sample 2 has an extremely large value and can be considered as an outlier. The value is now replaced with a newly randomly selected one, which is not an outlier anymore. For the updated sample, explain how the confidence interval will differ from that of sample 2 calculated in subpart 2b. So we'll say as the outlier value has been replaced, the sample size does not change, but the sample variance decreases. As the sample variance decreases, the width of the confidence interval will reduce. If the sample mean has also changed, then there will be a shift. Instead of S, I have written C. Should be shift in the confidence interval as well. Now let's see question number 3. Now here in question number 3, you can see part 1 is an MCQ style question. Now for MCQ style question, you don't have to write anything but just the A, B, C or D value. That's it, nothing else. So the claim amount X and Y in units of 1000 for two different types of insurance policy are modeled using a gamma distribution with the parameter alpha is equals to 5, lambda is equals to 1 by 8 and alpha is equals to 3 and lambda is equals to 1 by 4 respectively. That is, They have given the distributions. Assume that x and y are independent of each other. Identify which of the following options describes the moment generating function of x. So for moment generating function, we'll say that moment generating function is going to be 1 minus t by lambda raised to alpha from table book page 12. As I said, you don't have to write this because this is not part of the solution. You just have to specify the option, nothing else. So we get 1 minus 8t raised to minus 5. That becomes nothing but option C. Using moment generating function, show that 1 by 4 x follows chi-square 10. So here we do have to show everything, all the calculations. So we'll say let s be nothing but 1 by 4 x. So mst would be e raised to ts, expected value of e raised to t x by 4. So I will take t by 4 as my dummy variable and I get mx t by 4. So substitute, instead of t we will have t by 4 and we get 1 minus 2t raised to minus 5. We'll say by uniqueness property, we can say that this is nothing but a moment generating function of chi-square distribution. So therefore by uniqueness property, 1 by 4 x will follow chi-square 10. Calculate the probability that the claim amount x exceeds rupees 40,000. So because our units were in 1000, okay, units were in 1000, therefore we are looking for x exceeding 40. So probability x greater than 40, convert it into chi-square distribution and we will get from the tables value as 0.4405. An analyst argues that the sum of x and y must follow a gamma distribution 8, 3 by 8, that is x plus y follows gamma this. Comment on the analyst's argument using the moment generating function. First of all, we know that if we are adding two moment generating two gamma distribution, we'll get a gamma distribution only if the lambdas were same. Here our lambda were not same, so we are not going to get another gamma distribution, but we'll have to show that. So we are saying z is equals to x plus y. Moment generating function of z will just be moment generating function of x into moment generating function of y, because x and y are independent. You can write that here in bracket, independent, okay, as your reasoning for doing this, and that is going to be this. And if we assume another variable, let's say w, follows gamma distribution that they have given us, the moment generating function would be this, that is not equal to our moment generating function of z. Therefore the analyst's argument is incorrect. Now let's go to the next question. In question number 4, an analyst is working on renewal of health insurance policy. He has estimated the following aggregate claims statistic for 4 policies over last 3 years. So you can see in the first part we are actually doing EBCT here, EBCT model 1. Okay, so using EBCT model 1, compute the credibility premium of policy number 4 for the upcoming renewal. Students may refer actuarial table for the formulas. For those data, first thing that I calculated was x bar I and x bar I minus x bar whole square. So for that, first you will require x bar, that would be total x bar I divided by 4. Okay, again, if you are confused, look at the table book for the formula. Expected value of s square, again I have just substituted all the values and we get 4158. Variance of m theta is going to be this. So z turns out to be 0.956723. Okay, all of those formulas are given on table book page number 29. Okay, so the credibility premium that we are talking about, 54, is going to be z x bar 4 plus 1 minus z x bar, or you can write expected value of m theta. Okay, whatever you want to. Okay, that turns out to be this. Second part, the medical inflation in last few years is very high and increasing at a rate of 20% per year on average. Describe the adjustment to be made in the above estimation as determined in sub part 1 in order to incorporate the medical inflation. Also state any additional data that will be required. Okay. So for the second part, we'll say the average amount is assumed to be growing each year. We need to adjust the data to take account of this. Two approaches are, first is convert the data into year 3 values by increasing by 20% per annum and then applying the methodology above, because we are saying everything is increasing by 20% each year. So we are sort of calculating the values in terms of third year values. That means we are increasing each value by 20. First year value you will be increasing by 1.2 whole square. Second year value you will be increasing by 1.2. That means you are bringing it up to year 3 values. Or the second would be that recognize the lower volume of the data in earlier years by applying a risk volume to each year and using EBCT model 2. If the risk volume for year 3 is 1, then the risk volume for year 2 is 1 by 1.2, that is 20% less than year 3. And in year 1 it is going to be 1 by 1.2 whole square, that is 20% less than year 2. So we have made risk volume. Now you can apply EBCT model 2 there. Okay. So the data of year 3 years for these 4 policies will be required for this, because we don't have the actual data. We cannot actually solve here. Third part, explain without performing any further calculation what change is expected to the credibility factor determined in sub part 1 if the policy number 1 is excluded. Now see, we have 4 policies, out of which if we exclude the first policy, what are the different things that we will be seeing? First of all, total number of policies will go down. Okay. So that would decrease your variance, but also dependency of your Z on each of these policies will also increase. The rest of the policies we have only 3. So if number 1 is policy number 1 is executed, the data of all other policies will have greater weightage and the overall variance will decrease. This will in turn increase the reliability on each policies and Z will increase. Okay. Let's see question number 5. The joint probability density function of random variable x and y is given. Determine the value of k. So whenever we are talking about value of the constant k here, all we will be doing is double integrate with respect to x, with respect to y, and equate it to 1. That is probability, law of probability that addition of all should be equal to 1. So here we are doing integration, x going from 0 to infinity, y going from 0 to infinity. And this is what we have. First we'll integrate with respect to y. When we are integrating with respect to y, k is constant, x is constant. So I've kept exp minus 3x outside, okay, and integrated the rest. This is what we'll get. Then substitute the values and 5k constant outside. Now I will integrate this with respect to x. So we'll get this, and we get k is nothing but 3 by 5. Now you could integrate them together as well, because this exp minus or e raised to minus 3x is an constant when it comes to integrating with respect to y. So you can take this out directly and you will have 2 integration, one with respect to x and one with respect to y, and then you can solve them simultaneously as well. But this is easier, at least for me, so that is why I do it like this. So k became 3 by 5. Then in the second part, identify the right marginal density function of x and y from the following expression. Again, this is MCQ, so you don't have to show how you calculated the marginal distribution. So calculate it on paper. integrate with respect to y when you're finding marginal distribution of x, integrate with respect to x when you're finding marginal distribution of y. So you will get this and this. All you have to do is write your option when it comes to the MCQs. Part 3, state whether x and y are independent based on your answer in part 2. So we have our marginal distribution of x, marginal distribution of y. If we multiply that, we will get our f of xy. So therefore, x and y are independent of each other. Fourth part, determine the conditional density function of f of x given x is greater than 5. So first thing we'll do is find x is greater than 5, right? So probability x is greater than 5, integrated from 5 to infinity, you are going to get exp or e raised to minus 15. Our f of x such that x is greater than 5 would be f of x, probability x greater than 5. Okay, this is what we'll get, that is 3 e raised to minus 3 x minus 5, okay, where x would always be greater than 5. Okay, this is very important. In the fifth part, identify which of the following expression is equal to the conditional expectation of this. We can easily find conditional expectation after finding the conditional density function, but here you will see these are not written in terms of x. There is a reason that these are not written in terms of x, because we will be converting them in terms of t, because the limits you can see are going from 0 to infinity, right? 0 to infinity in each one of them, whereas we just said that this density function will be for x greater than 5. Okay, so we'll have to convert this for a variable t that will go from 0 to infinity. So first thing we'll be doing is let t be equal to x minus 5 such that t is greater than 0 then, because x is going from 5 to infinity. So t will be going from 0 to infinity. We'll say our expected value will be just this, going from 5 to infinity. So substituted the value. Now all I have to do is replace it with t. So x is going to be t plus 5, x minus 5 is going to be t. Now if I just give them two different integration, this is what I get, and that is d. Let's go to question number 6. The aggregate claim amount of health insurance policy, health insurance portfolio follows a normal distribution with mean mu, with prior distribution of mu is normal distribution. So this is our Bayesian credibility. For this distribution, a model has been built using n-sized sample data with the mean x bar, variance s square, and the credibility factor z. State the relationship, okay, increasing, decreasing, or nothing of the credibility factor with mu naught, sigma square, and s square, and provide the reason for same. So first of all, you will have to find what your z is. Now normal distribution is given in our table book on page number 28. So from page number 28, you just have to figure out what symbol are given in your question and what symbols are given in your table book. So accordingly, this is what we'll get. Our expected value of posterior mean is going to be this. Okay. So I've just rearranged, denominators, multiply this by s square, multiply this by sigma square, and so on both sides, and this is what we'll get. Now we can convert this into our credibility premium. So for x bar, okay, I had n sigma square, so just remove that, given denominator to both of them, and here mu naught will be our prior mean. So our z becomes n sigma square upon n sigma square plus s square. So I've divided both my numerator and denominator with n sigma square so that I have only one of those n sigma square. Now I can see the relation between them. So first of all, z is independent of mu naught. There is no mu naught independent. Then as sigma square increases, so here we have our sigma square, as sigma square increases, denominator decreases and z increases. Similarly, as s square increases, denominator increases and z decreases. You can even give the logical relationship that if sigma square increases, then variance of the prior distribution increases and hence reliability on the sample increases. And as s square increases, the reliability on the sample decreases and hence z decreases. You can write that ways as well. Let's see question number 7. We have housing prices xi in units of 1000 in the region x follows normal distribution with. Now usually whenever I have a long question, first thing I do is try to figure out what we are actually doing in this question. So here you can say calculate the probability that x region sample mean greater than y sample mean. Okay, so we have two samples x and y. Okay, so we are just working with the probabilities and different distributions. This is more like sampling chapter questions. Okay, so we have housing price xi in units of 1000 in region x follows a normal distribution with mean 500 and standard deviation 10 for I going from 1 to 10. For another region y, the housing price yj in units of 1000 are normally distributed with mean 510 and the standard deviation 5 for j going from 1 to 5. Assume that two samples are independent of each other. Let x bar and y bar denote the mean of the two samples and let s square x and y square s square y be the sample variance. Calculate the probability that the region sample mean is greater than the region sample, y sample mean. So here, first of all, we'll say our x bar would follow a normal distribution with the same mean and sigma square by n. Same thing with y. And then we'll say y bar minus x bar. Now the reason I have taken y bar minus x bar, just so that because mean of y was more than x, that's the only reason, nothing else. You can definitely write x bar minus y bar, no problem there. So we'll follow a normal distribution 10, 15. Now we want probability that x bar mean is more than y bar mean. So we'll say y bar minus x bar would be less than 0. Convert it into standard normal. We'll get this value. And the probability is going to be 0.00494. So almost 0.5% is the probability. For the second part, calculate the probability of sample variance of region X is greater than 100. So for sample variance, we know the distribution is going to be chi-square. So we'll say we want s square x greater than 100. Convert it into chi-square. So n minus 1 s square by sigma square would follow chi-square n minus 1. So we are getting it as chi-square 9 greater than 9. Probability is 0.4373. Third part, calculate the approximate probability for sample variance of region X is less than the sample variance of region Y. When you're comparing two sample variances, we will be taking F distribution. So for that we have, so this seems to be an MCQ style question. Okay. So I have taken s square y greater than sx square s square x just because of the variances. I want the lower variance upon the upper variance so that when I convert it into this, okay, what do I have? I have a value that is greater than 1. Okay, it's just easier. Otherwise you will have to convert this into 1 by f and stuff. Okay, so I just wanted the value to be greater than 1. That is why I've written sy square greater than sx square. So we'll say the ratio should be greater than 1. Divide by sigma y square and sigma x square, we'll get 10 square by 5 square, and we get f distribution 4,9 greater than 4. Probability is 4.2. I used interpolation to find the exact probability. Calculate the probability of region X sample standard deviation is more than 4 times greater than the region Y sample standard deviation. Okay, so now it will be flipped. So 4 times, so you can see I have written first like this, 4 times sy square should be greater than sx square, or actually less than sx square. So return it like this, and when we again convert it into f distribution, we will get f4,9 is less than 1 by 4. So therefore I will flip it and we'll get f 9,4 is greater than 4. The probability of that is 9.85%. Now let's jump to question number 8. We have defined conjugate prior distribution. The conjugate prior distribution, very simple, straight from book. Okay, we'll also see the second part. Assume that x1 to xn are random sample from an exponential distribution with the parameter lambda, where lambda is a random variable. Prove that the conjugate prior distribution for lambda is a gamma distribution. So we don't know the exact prior distribution, but we have to show if we take the prior distribution to be a gamma distribution, I have taken alpha comma beta, I'll get another gamma distribution as the posterior. So we'll say prior will be proportional to only this much. I have removed the constants. Likelihood will be this. Okay, from exponential distribution, so we get lambda raised to n e raised to minus lambda summation xi. So we'll get lambda raised to n alpha minus 1, n plus alpha minus 1, and e raised to lambda beta plus summation x. So it's nothing but a gamma distribution with the parameter n plus alpha and beta plus summation x. Hence the conjugate prior distribution for lambda is a gamma distribution. Next, if lambda follows gamma alpha comma beta, I think I read this first, and that is why I have taken the same value so that there's less confusion. Deduce that the expected value of n by lambda will be equal to this. So first let's find expected value of 1 by lambda for a gamma distribution. So lambda is equals to gamma alpha comma beta. Expected value of 1 by lambda. Remember here lambda is our variable. We are integrating with respect to lambda. Okay. So all we have to do is complete our PDF so that we get another distribution, or another gamma distribution rather, with a different, with a different parameter. So because here we will get lambda raised to alpha minus 2, what we have done is we have assumed a new alpha to be alpha minus 1. So return this in terms of PDF of a gamma distribution such that the parameter is alpha minus 1 and beta. Okay, so therefore I want beta raised to alpha minus 1, gamma alpha minus 1, lambda raised to alpha minus 2, e raised to minus beta lambda. So this becomes nothing but integration for all values. So this would be equal to 1, and that is why we are left with just this. So we get the expected value is beta by alpha minus 1, and we'll just multiply n, that's a constant. Therefore we get n beta by alpha minus 1. B part, Considering the distribution in part 2, show that the posterior mean of n by lambda can be expressed as this. Okay, so we want posterior n by lambda. Okay, so expected value of posterior n by lambda will be this. Okay, all I have done is substituted in our posterior distribution, substituted the beta, substituted the alpha. Okay, so we'll get this. So we can write it as n by n plus alpha minus 1 into summation x and plus alpha minus 1 upon n plus alpha minus 1 into the mean of prior. So therefore the z will be equal to n upon n plus alpha minus 1. Now let's see question number 9. We have Poisson distribution can be written as this in the form of member of exponential family. Identify correct option indicating the variance function, that is our v mu. Okay, so from the exponential form that they have given us here, we can figure out that our theta would be log mu, the b theta would be mu, and our a phi would be 1. Denominator is just 1. So here we go, theta log mu, b theta is mu, that becomes e raised to theta. We'll differentiate once, differentiate twice to get our variance function, and variance function becomes nothing but mu. That is option D. B part, identify the correct option indicating the mean mu and variance as the function of mu for the particular distribution when written in the form of member of exponential family. Okay, so b theta is given as minus log minus theta. Theta is minus 1 by mu and a phi is 1. So this is most likely from an exponential distribution. So b theta, we'll differentiate it with respect to theta. Okay. So minus 1 by theta and we'll get mu, and double differentiate it, I'll get 1 by theta square and we'll get mu square. So mean is mu, variance is mu square, and option is C. For the second part, a student modeling accidental hospitalization claim found that the interaction between age band and gender is significant. Explain what this means for the model predicting the accidental hospitalization claims with reference to the beta parameter of gender. So we just, and even here they are saying you are told that the male are more prone to accidents than female, and hence the male requires more accidental hospitalization compared to the female across all age groups. So we'll say when there is a significant interaction between a numerical variable and a categorical factor, the beta parameter changes with different categories of the factor. As there is interaction between age band and gender, the beta parameter will be different for different genders. And because we know male has higher value, so as male are more prone to accidents than female, the beta for male will be more than that of female. This is what we can talk about beta from the given information. Okay. B part, a student is fitting GLM model to predict policy renewal rate of a group of policies. See, they have specifically said for a group of policies, and we are trying to predict policy renewal rate. Okay, so for a group of policy, you can say the number of policies that are, okay, comment on the choice of the link function that can be used with the suitable expression. So let's read. Okay, for a group of policies of size n, the number of policies renewed will follow a binomial distribution with parameter n and p, where p is the renewal rate of the policies. You can say it is x by n, and x by n is what we take it as binomial distribution in our GLM. So for fitting GLM to the response variable of the renewal rate, canonical link function of binomial distribution should be used. That is, G mu is equals to log of mu by 1 by mu is equal to eta. You can look that up in the table book directly. Okay. Hence, linear predictor eta ranges from minus infinity to infinity will give the value of mu hat in the range of 0 to 1. So that tells us that it is a rate. That means sort of a proportion or probability. It should always be between 0 and 1. Third part, answer the following question using ANOVA table as provided. So they have given us the ANOVA table and ABC values are missing. Identify ABC to complete the table and calculate the F value when SS regressed for model 1 and SS regressed for model 2 are given. So we have two different models. So we will be making two different ANOVA tables. So because SS regressed is given, the A is nothing but the SS regressed. So for model 1, SS regress A value is 1.38, B value is going to be SS residual. SS residual is SS total minus SS regress, that turns out to be 4. And the C value is going to be MSS residual, that is SS regress, SS residual by the degree of freedom. That would be this 0.333. Same thing we have to calculate for model 2. A is SS regressed, B is SS residual, and C is MSS residual. Now they also asked us to calculate the F values. Okay, F values in part A that I did not calculate here, but I think I have calculated it later. So anyways, you should write here the F statistic values. That is our MSS regress divided by MSS residuals. See, you can see here for B part I have done here. Let's see. Okay, they have said to write down the F values here, so you should definitely write it in part A. B part, comment on the result in part A above using tabulated values provided below, clearly stating the hypothesis. So they have given us a few values of F 1,12, 1%, 2.5%, 5% and 10%, so that we don't have to use our tables. So here I have calculated for model 1 H naught beta equal to 0 and beta not equal to 0. I've calculated the statistic here 4.14 for model 1. The p value is going to be between 5% and 10%. Similarly for model 2, the statistic is 9.52. P value is less than 1%. So what can we conclude? At 5% level, we have insufficient evidence to reject H naught. That means model 1 does not have a linear relationship. Beta is 0. But here at 1% level, we have sufficient evidence to reject H naught. Model 2 does have a linear relationship. That means beta is not equal to 0. C part, comment on the suitability of model 1 and model 2 using R square. Note the students are required to provide the calculation of R square separately for model 1 and model 2, clearly stating the formula. The R square formula can be calculated from SS values. So our R square is SS regressed by SS total. So here you can see for model 1 we have this, for model 2 this. Only 25.65% of the data is represented by the model. The linear relationship is very weak. And here 44.24% of the data is represented by model 2. The linear relationship is not strong but better than model 1's, because 44% is still not a very good relationship, but okay, it's better than model 1. In the fourth part, a statistician is comparing models using R. He observes the following result using R software. Result 1, analysis of deviance table. Okay. First model 1 is Y follows 1 and model 2 is Y follows X. Okay. I can look at directly the p-value or the significant stars. Okay, so p-value is very, very small. Okay, first of all, what are we supposed to do here? Okay, comment on the new result and model that you would prefer with reasons based on the result in part A and B. Okay, so we have result 1, result 2 and result 3. You can look at the p-values. Here p-value is very small, here p-value is still small, and here p-value is very large. So we'll say result 1, as p-value is very small, model 2 is significantly better than model 1. Result 2, as p-value is significantly small, less than 1%, good enough. So model 2 is significantly better than model 1. Okay, so here this is preferred among these two. Okay, is preferred model. And result 3, as p-value is 92%. Okay, so model 1 is significantly better than model 2. The interaction, so what can we conclude? Okay, so this model is better than this model. Okay, so interaction between X and region is not significant. So because this is independent model between X and region, this contained interaction between those two as well. So the interaction between X and region is not significant. The independent model between them is better. Okay, so therefore this model is preferred model amongst all models. So most of the questions here were very straightforward, very easy, and the time allotted, that was 3 hours and 30 minutes, was plenty enough for us to complete the paper. If you find any mistakes in the solution, do write it in the comment. As the institute releases CS1 paper B, I will also make the solution for that. So please like, share and subscribe so that you will get notification for that as well. I'll see you in the next one.